Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am one of the math specialists here at the Learning Liaisons, and I just love spending Wednesday night math. I just love spending Wednesday nights with you, working through some problems, helping build your competence and confidence in what you're trying to do. And that is pass that certification exam. And so that is really why we're here, is to help build that competence and confidence in you, to just help you feel like you can do it, because we know you can. Remember, it's not if you pass, it's when you pass. And so we know you can, but we are here to help build that in you. So I am from Central Florida. I am a lover of all things math. I also love choreography and dance, and I do that kind of on the side for local theater programs. And and I have a Great Dane and a cute little family. So that's enough about me. Let's go ahead and in the comment box, let me know where you're from, what test are you prepping for, and the get to know you question. If you could choose any ice cream flavor, what would it be? And I am just saying that because I am thinking about ice cream right now. So if you could choose any ice cream flavor, what would it be? I usually go for something with like peanut butter, chocolate, caramel, but not like a chocolate base. I do not like a chocolate base ice cream. I think it's absolutely disgusting. But if you mix the chocolate sauce into the ice cream, I'm good with that. I know it doesn't make sense, but anything that has chocolate, peanut butter, caramel is my jam. I also like birthday cake, except I have a gluten allergy, so I can't usually find a birthday cake ice cream that is gluten-free. Although we went to an ice cream place today that actually had gluten-free birthday cake ice cream, and I was in heaven. I was like, thank you for having a gluten-free birthday cake for us people with gluten allergies. And so that made my day. So that was a big deal. So, comment box, where are you from? What test are you prepping for? And what's your go-to ice cream flavor? What's your go-to ice cream topping too? Like, let's talk about all of it. I could put chocolate sprinkles all over my ice cream. I'm really a child. Chocolate sauce, caramel sauce, anything that's like decadent like that. Gummy bears can stay off, although my son thinks that he wants gummy bears on top of his ice cream every single time. And I think that that's so gross. But yeah, anything Reese's peanut butter cups. I used to love Cold Stone. I don't know what happened to Cold Stone. I haven't seen one in forever, but I used to love that you could pick like full-blown candy bars and they would mash them up into your ice cream. I thought that that was so cool. So yeah, it was like create your own ice cream flavor. Anyways, let's go ahead and jump into the first problem. I will be doing problems that range from pre-K through 12. If you have something that you want to see me go over in the next week or so, please let me know and I'll add it to my next week section. I actually had somebody specifically request a couple of problems this week. And so those will be included in this week's Wednesday math night. But if you have problems that you want me to specifically go over, please don't hesitate to reach out to me. Find me in our customer hub, find me on Facebook and tag me, because if you don't tag me, I probably won't see it. But tag me and let me know, because these math sessions are for you. They're not for me, although I love doing them, but they are to help you feel more confident. So if there's something you're struggling with, just let me know and I will be happy to include it in the upcoming sessions. All right, without further ado, let's go ahead and start with our first problem. A teacher posed the question, what is the sum of 8 plus 7? When you answer the question, I would like for you to explain your reasoning. The teacher calls on student number 1, and the student provides an answer, but does not provide or explain their reasoning. What is the best teacher response? A, accept the answer and move on to the next question. B, ask the student to explain how they arrived at their answer. C, rephrase the question and ask a different student to explain. Or D, provide the full explanation yourself to model correct reasoning. All right, so we have a teacher. Now, this is a problem. Someone specifically requested that I do a couple scenario-based questions that are pre-K through 3 related, because on that test, there's not a whole lot of practical solving, but a whole lot more of this scenario-based kind of stuff. So a teacher asks, what is the sum of 8 plus 7? When you answer the question, please explain your reasoning. And then the teacher calls on the student, and the student provides the answer to 8 plus 7. So the student probably says something like 15, because that's the actual answer. But the student does not explain their reasoning. What is the best student or teacher response to that? Accept the answer and move on. Well, part of this discussion was the teacher wanted to know what the reasoning was. So you don't want to accept the answer and move on, because the student hasn't completely answered the question. And while it may not seem like a big idea in this moment, the student needs to understand that when you ask for something, they need to do it. And you don't want to shame them or ostracize them or anything like that. Maybe they forgot to explain their reasoning. Maybe they're not really sure how they got to their answer, but we want to encourage that. And we want to encourage that through our classroom culture. And so we don't want to just blindly accept that answer and move on. B, ask the student to explain how they arrived at their answer. So we say, what is the sum of 8 plus 7? When you answer the question, I would like you to explain your reasoning. Student says 15. The next piece of that would be, can you explain to me how you got that? That opens the door without that embarrassment factor of, hey, can you share with us what you did? You got the right answer. Absolutely. Because maybe that student's not confident. Yes, you got the right answer. Now, how did you get there? And then if the student says, well, I really don't know, there's your anecdotal evidence to say, I need to pull this student aside and kind of figure out like why they're struggling to explain their answer. Then I might go to another student and ask them to explain their reasoning or something like that. But we want to give that student the opportunity to explain their reasoning. rephrase the question and ask a different student to explain. We haven't given the first student the opportunity to explain their reasoning, so we want to do that first. And provide the full explanation yourself to model correct reasoning. That ideally would have already been done and modeled at the beginning of the year. And yes, we do that constantly as we are teaching, but at this point, we want the students to be able to lead that discussion, and we want the students to discover that learning. And so we want them to explain their reasoning, because the way they solve the problem might be very different than the way we solve the problem. In the way that we learned how to do this, we learned how to memorize, or we learned the old school way, right? However, there are lots of different ways that students arrive to their answer, and you never know, a student might learn from another student. So having this discourse in mathematics is really important. I kind of got on a soapbox there because I did teach first and third grade, and this is kind of my like niche. And so you just got me on a soapbox, but now you understand what the answer is, and let's go ahead and move on to problem 2. As we are working together today, don't hesitate to ask any questions that you might have in the comment box. I am happy to answer them, so don't hesitate to ask. A circle is drawn on a coordinate plane. The circle has a diameter that intersects the circle at points A and B, which are 7, -4, and 9, 6, respectively. Which of the following represents the equation of this circle? Which of the following represents the equation of this circle? All right, so we have 4 different equations represented here. The first thing we need to know is, what is the equation of a circle, right? So the equation of a circle is x minus h squared plus y minus k squared equals r squared. X minus h squared plus y minus k squared equals r squared, where r is your radius squared and hk is your center. Now you notice that in this equation, I have minus signs or subtraction signs as the original part of the equation. And the center is h, k. So we see that the original equation has x minus h and y minus k. So if my center is a positive h and a positive k, I'm going to have minus signs. If my center is a negative h and a negative k, then it would be x minus a negative h, which would turn that into a positive. So it's kind of opposite of what we would expect, right? And that's just something we need to consider. And then my radius is radius squared, r squared. So what information have they given us? They've told us that the circle has a diameter that intersects the points A and B, which are at 7, -4, and 9, 6. So those are the points of my diameter. And if I graph this over 7, -4, and over 9, up 6, there's my diameter. So my circle looks something like this. I did not count that out for a reason. I don't need to, because I have formulas that can help me with this, but just for visualization, that's kind of what we're looking at. And I need to figure out what my center is. And I need to figure out what my radius is, right? Those are my 2 pieces of my equation. And so in order to develop my equation, I need to figure out what that center and what that radius are. How do I figure out what the center is? It's going to be somewhere around there, right? Well, if I have a line, which is a diameter, I know my center is going to be in the middle of that line segment. And so I can use my midpoint formula. If I find the midpoint of this line segment, if I find the midpoint of that specific line segment, then I can absolutely figure out what my center is, because the midpoint of my diameter is going to be my center, right? So I'm going to use that midpoint formula, which is x plus x divided by 2 and y plus y divided by 2. And that's my midpoint formula. So I'm going to do 9 plus 7 divided by 2, 6 plus negative 4 divided by 2, which equals 9 plus 7 is 16 divided by 2 is 8. 6 plus negative 4 is 2 divided by 2 is 1. So my center is at 8, 1. Test taking strategy. Don't solve for the radius until you use the first part of your answer to figure out which answers you can eliminate. My center is at 8, 1. So in looking at this is not a center of 8, 1. A and C are automatically out because they don't represent a center of 8, 1. And then when I look at B and I look at D, I have a radius squared of 26 and a radius squared of 104. But there's another difference. And that other difference is the fact that this one has subtraction signs and this one has plus signs. If my center is naturally positive, then I'm going to end up with a negative in my original formula, which means my answer is B. Y'all, I just saved myself a ton of work because I didn't need to find my radius because there was only one possible answer choice with the center that I found, which was the easiest part of the problem. Now, I will show you how to solve the radius today, but I want you to see that using that test-taking strategy just saved you probably 2 to 3 minutes because the distance formula does take a little bit of time. Let's go ahead and look at that right now. So in order to solve for the radius, I'm going to use the distance formula, but I'm going to do the distance formula between one of these 2 points and the middle. I'm not going to do the distance of this entire thing because I don't want the distance of my diameter. I want the distance of my radius. And because I've already found that midpoint, I can find an accurate distance. I don't have to do an extra step of dividing by 2. And so I am going to do the distance formula, which is the square root of x minus x squared plus y minus y squared. So I'm going to do the square root of, and I'm going to use this point and this point, 8 minus 7 squared plus 1 minus negative 4 squared. 8 minus 7 is 1 squared. 1 minus a negative 4 becomes a positive. So that becomes 5 squared. So this equals the square root of 1 plus 25, which is the square root of 26. Remember, this equals the radius, and this is the radius squared. So if I do the square root of 26 times the square root of 26, I just get 26, which matches the answer choice that I've already chosen. Does that all make sense? But now you see and you can understand the steps that we took to get there so that you understand even more how to use your time wisely when you're taking these kinds of tests. Questions? Let's go ahead and move on to problem number 3. Which of the following demonstrates the use of the commutative property of addition? Which of the following demonstrates the use of the commutative property of addition? All right, so this is something everybody in the room needs to know. The commutative property of addition means that I can add, because we're talking about addition. Yes, there is a commutative property of multiplication as well. But in this case, we're using commutative property of addition, which means I can add in any order and get the same answer. So that means that 3 plus 8 is the same thing as 8 plus 3. That is what the commutative property of addition is. So let's take a look at our answer choices and see what we've got. We have A parentheses B plus C parentheses equals A times B plus A times C. That demonstrates the distributive property because I am distributing all the way through. So that's not the correct answer. A plus parentheses B plus C parentheses equals parentheses A plus B parentheses plus C. This is the associative property, which says that if I have 3 addends, I can choose which addends I want to add first. I can move the parentheses because in order of operations, I do what's in the parentheses first. And I can move those parentheses and add B plus C first, or I can add A plus B first. But the order of the addends stays the same. C, A plus B plus C equals C plus B plus A. This is absolutely the commutative property. I'm adding my addends in a different order, and so that is the commutative property. And D, A plus 0 equals A. That is the identity property of addition. Because what I'm adding to A doesn't change the identity of who A is. A equals A. So by adding 0, I'm not changing who A is. A is staying the same, and so that's why it's the identity property. All of these properties are properties that everybody needs to know, pretty much 3rd grade through 12th grade, and so everybody needs to understand what these properties say and do. All right, let's go on to the next problem. A cake company is building a cake structure for an event. They need to create a cake in the shape of a triangular prism. The cake must be divided into 3 equal sections that will be 3 different flavors. If the entire cake has the dimensions below, what is the volume of one of the sections? What is the volume of one of the sections? All right, so a cake company is building a cake structure. So we're like going Buddy from Cake Boss-esque here. And they need to create a cake in the shape of this triangular prism right here. And it must be divided into 3 equal sections. So we have a chocolate section, and we have a vanilla section, and we have a mint section. And all 3 sections are the same size. So we have the blue section, and then we have the green section, and then we have the pink section, and they're all the same size. If the cake has the dimensions below, what is the volume of one of the sections? So volume of a prism equals area of the base times the height of the prism. And area of base. Remembering that in a prism, we have 2 identical bases and then rectangles connecting those 2 bases. So if this is a triangular prism, my bases are going to be triangles. Mathematicians are not very creative when they name things. And so in this case, a triangular prism has triangle bases, right? And so I have a base here, and I have a base here. Those are my two bases. So if I'm doing volume equals area of my base times my height, then what I'm going to do is I'm going to find the big B is going to equal 1/2 base times height, because area of a triangle equals 1/2 base times height. In this triangle, my base is 18, and they actually gave me my height is 21. Remember, your height is going to be perpendicular to your base. It's not your slant height. So this is going to equal 1/2 base 18 times height 21. I am going to use my calculator for this one. (18 times 21 divided by 2, which is the same thing as multiplying by 1/2, equals 189. So my volume of my prism equals area of base, I already solved for that, 189, times the height of my prism. The height of the prism is going to be the distance between the two bases, 24. So 189 times 24. And that equals 4,536 inches cubed. I know that we disconnected. My iPad just likes to do that sometimes. So we're just going to reconnect. No big deal. So I have found the volume of my triangular prism, right? I've found the volume of my triangular prism. And with that, I'm now going to read my question again, which is always a good thing to reread that question before I answer, just to make sure I'm answering the right thing, right? So it says, let's remind ourselves, if the entire cake has the dimensions below, what is the volume of one of the sections? So this is the volume of the entire cake. I want to know what the volume of just one section is. So I'm going to divide that number by 3 to get the volume of just one section, which is 1,512A. Questions about that? All righty, let's move on to problem number 5. A function table is shown below. What is the rule that is demonstrated in the table? What is the rule that is demonstrated in the table? So a function table is just a table that has an input and an output. So for my upper level people, that might not be a foreign word to you, but for my elementary people, this might be something where you're like, whoa, functions, we don't have to do all of that. Well, you do need to understand input, output. You do need to understand rules that go from the input to the output. This can also be known as our X and our Y. And so you do need to understand all of that. And when we look at the rules on the left, we can kind of see what we're dealing with. So A, multiply by 4. Is 2 times 4 equal to 8? Yes. But what I caution you on is using the rules and only applying them to the first row of that function table. Because sometimes, and we're going to see this with this example as a matter of fact, sometimes there's going to be multiple rules that work for that first row, and the rule has to work for the entire table. The rule has to work for the entire table. So we can't just say, oh, it works for the first row, we're good to go, because that's not the case. Multiply by 4. Is 2 times 4 equal to 8? Yes. Is 4 times 4 equal to 12? No. So multiply by 4 is not going to be our rule. Add 4. Is 2 plus 4 equal to 8? Nope. So we know it's not B. Divide by 2 and subtract 1. Well, I know that's not going to be correct because I'm not going to divide this by something and subtract something and get a bigger number than what I started with. So let's go ahead and look at D. Multiply by 2 and add 4. 2 times 2 is 4, plus 4 is 8. Now let's keep working it down. 4 times 2 is 8, plus 4 is 12. 6 times 2 is 12, plus 4 is 16. 7 times 2 is 14, plus 4 is 18. We have found the rule that works. Remember, in an input-output table where we're looking for a rule, where we're looking for something like that, we want to make sure that we're not just applying it to that first row and saying, got it, but that we are looking at the entire table to make sure that they're not trying to trick us like they did here. Let's go ahead and move on to problem number 6. A function table is shown below. What is the rule that is demonstrated in the table? What is the rule that is demonstrated in the table? So again, we have an input-output table here. And in this case, we have a series of y equals, right? We have a series of y equals. So if this is my x and this is my y, what I'm going to do is I'm going to plug in my x into here and see if it spits out my y. I'm going to plug my x into my x values in here and see if it spits out my y. Now, what I'm going to do is I'm going to look for the easiest input value to plug in to see my output value. Plugging in 0 is probably one of the easiest things to plug in. So I'm going to plug in 0 into all of these and see which one spits out a 3. I'm going to see which one of those spits out a 3. So y equals 3 times 0 plus 3. 0 plus 3 is 3. That works. I'm going to continue to see if there's any others that work. Y equals 0 plus 3. That equals 3. So that one works too. Y equals 0 plus 6. That equals 6. C is out. Y equals negative 3 times 0 plus 3. 0 plus 3 is 3. That one works too. So I've eliminated one answer. Now I'm going to plug in another one, and I'm going to pick which one I want to plug in. I'm going to choose to plug in this one right here. So y equals 3 times negative 1 plus 3. 3 times negative 1 is negative 3 plus 3. Negative 3 plus 3 is 0. That does not equal 6. A is out. Y equals negative 1 plus 3. Negative 1 plus 3 is positive 2. That does not equal 6. That's out. Y equals negative 3 times negative 1 plus 3. Negative 3 times negative 1 is positive 3 plus 3 equals a positive 6. We have found our winner. D is the correct answer. Questions about that? So I plugged in the easiest answer choice first into my equations to produce an input-output. And then once I narrowed that down, then I found my next easiest to me. Now, you could have plugged in 2 instead. You would have still gotten the same answer as me. You would have had different equations up here. These would have been different, but you still would have gotten the same answer, as D is the only one that works. Okay? Let's explore problem number 7. When teaching first graders how to make 10 to add 2 add-ins, which of the following teaching strategies should the teacher do first to introduce the concept? Which of the following teaching strategies should the teacher do first to introduce the concept? A, draw a picture of the 2 add-ins and represent how to make 10 using a 10 frame. B, use an equation to show the 2 add-ins and how they can be broken apart into making 10 to make it easier to add. C, use red and yellow counters to show the 2 add-ins and then manipulate them into 10 frames to show how to make a 10. Or D, focus on the fluency of the facts of the 2 add-ins as first graders need fluency within 20. All right, so we are teaching first graders how to make 10 to add add-ins. Which of the following strategies should the teacher do first to introduce the concept? Which of the following should they do first? So when we talk about this, and this is another one of my soapboxes, when we talk about the progression of mathematics, we think about teaching mathematics concrete, then with pictures, and then abstractly, especially in the younger grades, but this really works for everybody. So if we're doing concrete, that means that students are manipulating math with their hands. They're using manipulatives. That's why we have them. And so if we are trying to teach them how to make 10 to add, which really, if that's not a strategy that's familiar to you, that's like doing 8 plus 5 and then saying 8 is the same thing. This is the same thing as doing 8 plus 2 plus 3 because I broke the 5 into a 2 and a 3. So that equals 10 plus 3, which is 13. And I know what some of you are thinking. I don't understand why we do that. Why do we do that? That's not how I learned it. I just learned how to do 8 plus 5, and that just equals 13, or 8, 9, 10, 11, 12, 13. Why do students need to know how to do this? You're right. That is, it does seem like it takes longer. However, what this does is it builds number sense into students. It starts to build the foundation that students need to know when doing something like this. 28 plus 15. When I do 28 plus 15, 8 plus 5 is 13. But really, I have 3 1s and a 10. And so by having students manipulate numbers like this, it's building the foundation for base 10 understanding in a way that they can conceptualize, and in a way that we're not actually telling them, hey, this is what you're getting ready for, but we're getting them ready for that. So that's why this strategy is so important, and such an important strategy not to skip over. However, this strategy makes no sense at all if we don't start with the concrete model to show them, hey, we're creating a 10. Hey, we're creating a 10. Hey, we're creating a 10. Otherwise, it just looks like we're adding extra steps for no reason, right? So all of that to say, what should the teacher do first? They should absolutely start with something concrete, right? And so draw a picture of the 2 add-ins and represent how to make a 10 using a 10 frame. Not a terrible strategy, but that's a picture. And that's still going to be very abstract for first graders if we don't give them the opportunity to play with the math with their hands. Use an equation to show the 2 add-ins and how they can be broken apart. That's what I just did. And some of us were confused, right? And so that's going to be wildly confusing for 6 and 7-year-olds. We need to be able to show them concretely what's happening before we get all the way to an equation. This is like last step, not first step. Use red and yellow counters to show the 2 add-ins and then manipulate them into 10 frames to show them how to make a 10. All day, that is the correct answer. And then focus on the fluency of facts, because first graders need fluency within 20. They do need fluency within 20. But fluency within 20 means nothing if they don't understand what they're doing, right? They can memorize that 8 plus 5 is 13 all day. However, if they don't know what 8 means and what 5 means and why 8 plus 5 actually is 13 and that 13 is a 10 and 3 ones, then that memorization is useless and that standard is not actually met to the depth in which we want it to be met at. Now, I want to show you what this looks like with red and yellow counters. So I have a 10 frame. And yes, this is me on my soapbox, but this is appropriate for my pre-K through 3 people who really don't ever get a whole lot. Like we do so much in the like 4th through 9th grade world that our pre-K through 3 people really don't get a whole lot. So we have 8 plus, and we have red and yellow counters, but I don't have yellow. So we're going to do 8 plus purple, red and purple counters. And so I am going to take 8 and I'm going to fill in my 10 frame. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put my 5 below the 10 frame. Okay. 1, 2, 3, 4, 5. And mind you, I'm doing this with my hands, right? Like I'm not drawing a picture of it when I first introduce it, but I don't have red and yellow counters at my house. Then I'm going to tell my students, what could I do with this? And hopefully a student says, wait a minute, you could move 1, 2 inside, and then it becomes 10 plus 3. So 8 plus 5 is the same thing as 10 plus 3, which equals 13. And hopefully, eventually, with us doing this over and over, students begin to see, I know 8 plus 2 is 10, so I can break this 5 into a 2 and a 3. What we don't want to do is we don't want students doing 8 plus 5 is the same thing as 8 plus 1 plus 4. That's not helpful. Like, yes, they can break the 5 apart, but we want them breaking it up so that we can create that 10. Does all of that make sense? That was a lot of information, but I wanted to just kind of build that foundation as to why this strategy is so important. All right, let's move on to the next problem. The point -3, 5 is graphed on a coordinate plane. Which of the following points lies on the same line as -3, 5 with a slope of -2? Which of the following points lies on the same line as -3, 5 with a slope of 2? Now, I have heard that when some people take these tests, the scratch paper that is given is like grid paper. That's what I've been told. I don't know, but let's say that what I did get was grid paper. In that case, this problem is super easy. I have a point -3, 5 graphed on a coordinate plane. Remember, when we're looking at a coordinate point, it's an x, y. So I'm going to go over, then up or down. So because it's a -3, I'm going to go to the left, and then I'm going to go up 5. 1, 2, 3, 1, 2, 3, 4, 5. And I want the slope to be a -2, which means that my points need to fall in this direction from my line. Not in this direction. Those would all be positive lines. I need them to be negative lines. So when I look at this, over 1, down 1. Whoops. Over -3, -2. 1, 2, 3, down 2. -1, up 1. Or -2, up 3. Okay, those are my points. Those are my choices. And I want a slope of -2, right? So I want to go rise -2, run 1. Well, wait a minute. I actually just landed on that little point. So that point is -2, up 3. There's my winner. Now, I'm not confident in myself that I drew that accurately. So what I'm going to do is I'm going to check it with the slope formula. Slope equals rise over run, which is y minus y over x minus x. So I'm going to do the y minus y over x minus x with these 2 points. 5 minus 3 over -3 minus -2. 5 minus 3 is 2. -3 plus 2 is -1, which is the slope of -2. So that is the winner. All right, we have time for one more problem, and then I'm going to turn it back over to Dr. A. I skipped that problem because I want to do this one today, and then we'll go back to that one next week. What is the area of the blue shaded part of the figure below? What is the area of the blue shaded part of the figure below? So this figure we can see is a square. If I filled in all of this stuff, right? This is a square. Now, the question would probably say something to the effect of like a circle is inscribed inside of a square so that we are confident that these shapes are what they are, right? But I know in order to solve what that blue shaded area is, I need to do area of the square first, minus area of the circle second, and then minus the cutouts. So if I find all of the yellow, and then I take out this circle in the middle, and then I take out these cutouts, then I will have the blue shaded area. Well, if the diameter of this circle is right here, and the diameter is 6 plus 6, which is 12, then I know my length of my square is 12 because I can connect a diameter there too. So the area of my square is going to be 12 times 12, which is 144. So I know E is out because I know I need to do 144 minus the circle minus the cutouts. Area of a circle equals pi r squared. I know my r is 6. So I can do 3.14 times 6 squared, 36 times 3.14, and I'm going to use my calculator for that. Equals 113.04. So 144 minus 113.04 equals 30.96. Y'all, at this point I have my answer and I don't need to do anything else. What is my answer? A. Because square minus circle equals this. So it can't be any bigger than that. And I still need to cut out all 4 of these corners. So if I need to cut out all 4 of those corners, then I need to subtract something else from this item right here. Now, how would I figure out what those corners even equal? Well, I know that this distance right here is 2. That is the radius of a circle that looks like this. And this is a quarter of that circle. But wait, this is a quarter, this is a quarter, this is a quarter. So I have a whole circle, don't I? So I can just do area of another circle equals pi r squared. 3.14 times 4 12.56. And when I do all of that in my calculator, I get A as the answer. Such a fun problem, right? Like that's actually a super fun problem. All right, all that to say, let me know in the comment box what you want to see me go over in the upcoming weeks. I look forward to seeing you next week for Math Wednesday. I am always here to help you, so don't hesitate to reach out on the Customer Hub or on one of our Facebook pages. Tag me at Amy Sink, and I will be happy to help you. And if I don't hear from you there, then I'll see you next week. I look forward to seeing you then, and I hope that you have a fantastic rest of your week. I'm going to turn it back over to Dr. A. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.